three-phase 60 Hertz line connected to three identical capacitors connected in delta, as shown. Okay, so although I don't look like it, those capacitors are effectively connected in delta. Alright, and you might want to just draw them in delta. That way they're drawn up there is a common way to see them drawn on electrical schematic diagrams, things that are connected in delta. We got a line current to each of these of 22 amps. And the question is asking you to calculate the value of each of those capacitors. How can we go about tackling that problem? Yeah, you can. We've got to head towards something to do with Ohm's law to get the impedance. Another name for the impedance of a capacitor is its capacitive reactance, or XC. If we can get to that, we know the frequency. We can get out of it what the actual value of C is. Because ultimately, we know that XC is equal to 1 over 2 pi FC. So we can easily rearrange that formula to find that. So the key to this problem is, how do we find that value? Yeah, we've got the frequency. So if we can find the value for that, we can find C. We're almost working backwards from what we're looking at. How can we find that? Well, we've got a frequency, so we can find the capacitive reactance. We can rearrange that formula to find C. So how can we find the capacitive reactance? Yeah, you know 550, yeah, I didn't put that on here, did I? 550. So that's the line voltage. And we know, you could do, phase voltage in delta is exactly the same in it. So we've got the phase voltage. What you're saying there is, let's isolate one capacitor. We want to know the value of one capacitor. So let's isolate it. In fact, we could even say, let's draw just one capacitor, 550 volts. Isn't 22 amps though, is it? Yeah? So what that process of isolating that capacitor has, again, headed us towards, we call this I phase, don't we? How can we find that? We got no ST, Alan, have we? That would be a good idea, but I haven't given you that. I'm a right bugger like that, am I? What have I give you? I haven't given you S, but I have given you something else you ain't used yet. We've got EL. What else have we got? IL. What's the relationship between I phase and IL in a start delta connected system? Is that less than that or more than that? Is IP less than IL or more than IL? Less than, so it must be over root 3. Yep. 22 over root 3 equals. We could calculate that or we could substitute in, don't matter. I made that. Please check, but I made that 12.7 amps. Yeah. So we've got that. We've now got that. If this was a resistor, what would you do to find the value of resistor? Yeah. You'd say R is equal to 550 or E line over IP, wouldn't you? But what's R for a capacitor? XC. XC is equal to E line over I phase 550 over 12.7 equals. And I think I made that 43.3 ohms. And the last bit is to substitute that into C is equal to 1 over 2 pi f XL 1 over 2 times pi times 50 hertz, was it on the diagram? 60 hertz times 43.3, and I got 61.3 times 10 to the minus 6 farads, which in old money is 61.3 microfarads. Yep.